everyone, to another episode of Reliability BoomBox, proudly brought to you by Reliability Extranet Group of Companies. I'm here with my good friend, colleague, mate, Seven. Peter, welcome back.
How you going?
And today we don't usually do this, but we are celebrating. We've had a little bit of a win in our world with a couple of things coming off and coming to fruition. So we're having a beer. So we're just going to cheers to show this nice and relaxed. We do take things quite easy, but I actually got on the phone to Seven earlier today. I said, we've had some wins. Let's do something a little bit different. And let's talk a little bit about success. So, Seven, before we dive into what's actually on the screen, because I'm just going to let that sink into people at the moment, that little background.
Yep.
And we'll go through that because you were just sharing something before we started that was pretty exciting. And again, just another thing to celebrate, really. But I know in your book, the one that you kindly advertised just to your side there,
yes,
you talk about success and the importance of celebrating success. Give your view on that.
Oh, my view on it, that it has to be done. Well, you think about our world, Dane. So think about the maintenance and reliability world, right? And our, I'm going to use the word environment, the standard environment in the maintenance and reliability world. Okay, so we're doing maintenance, routine maintenance. Okay, or we're fixing breakdowns to really put it into that context.
Yeah.
And when you have a breakdown, there is usually a whole heap of hurt, pain, money going out the window, type things, stress levels going up, and all of that sort of stuff. And I think in our environment, celebrating success is a hard thing to do because of that. Okay. Because we're doing the routine stuff, right? We're doing our inspections, taking our oil samples, all that sort of stuff. Tighten, lubricate, clean, TLC type stuff. We don't, typically enhance things or make things better from a machine point of view, because that's usually a project design or something like that. We usually get handed over that stuff and usually have to fix it. So, because it's not performing and blah, 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 blah. I've been there too, don't worry. Hello to all the project managers out there too. Anyway, so I think celebrating success is a hard thing to do in our world, because what is success for us? Okay, what is success for us? Now, a lot of people put success on turning a breakdown around really, really quickly. Yeah. We've had this breakdown, we turn it around, and there's all the high fives and everything like that going on. When everything's over.
Yep.
Cool. And then we go back to routine.
Yes.
Okay.
Yep.
So when I was in my corporate life and in a managerial role, at the end of the month, we always would have a barbecue. Okay.
Yep.
I would cook the barbecue, and for those that have got the book, will probably see some diagrams in there of Gilbert cooking the barbecue. That was done on purpose, by the way. And we would always have a chat about the month. Okay, what happened this month, or the month that had just been completed? And I would focus on the things that we got right, or the things that didn't happen, or the things that we found, okay, in the inspections, and made that sort of point. And so we started talking about celebrating successes. From a production point of view, in my corporate life, we were in lean meetings and stuff like that, and you've got 10 to 15 minutes of a morning to talk about the state of the nation. As a suggestion, if you're not doing this already, and this as well. Ask the people what went well yesterday.
Yeah.
A very small celebration of success. Okay.
Yeah.
What went well? Okay. So in the maintenance and reliability world, what did we prevent? Okay. What did we find on our inspections that we have repaired? Okay.
Yeah.
Because if we didn't find it, that would end up with, essentially a breakdown. So we need to emphasize that. So I find it, I think it's really, really important to celebrate your successes. Okay. And I recognize the fact that it's really, really hard to do in our environment, because we're sort of, we're either doing routine or fixing breakdowns. Breakdowns are not necessarily a success. Okay.
The success, if you turn it around quickly, is good, and to get it going again is good.
Yeah.
It still broke down. So.
It still broke down. Okay. Yeah. But celebrate the wins where we haven't had the breakdown and we've found things through our inspections. Our inspections are actually working well. We did this RCA and we found the cause and we have implemented the change.
Yes.
Success. Yes. Celebrate that. So talk about all the things that you've implemented, okay, to prevent those failures, and concentrate and focus on that. And I'll be one of the first people to put my hand up and say it's hard in a managerial role in a reliability and maintenance world, because we're generally dealing with some sort of catastrophe.
Yep.
Yeah.
Awesome.
Yep.
Awesome. Yeah, and I think that's what came to my mind was when we had our little win in our team for us. And it's like, okay, hey, let's celebrate this. Like, I felt really good. We'd had some good news. You'd had a good story of something that happened, and we'll talk a bit more again about what's flashing through the screen for those that are watching it. But I remember too, in my corporate role in my life, like that was actually probably something I didn't necessarily do frequently enough, was celebrate little wins. Because you're often so head in the trenches, just trying to get things done. Just trying to get through, just trying to get it over. And it is important, like you said, I'm glad you really touched on the point of the RCA. It's like, when we do an RCA, like, okay, we've got a shitty situation because it's often a failure that's happened, or it's something that needs to be investigated. It's something that's gone wrong, right?
Yep.
Or it might be just something you want to improve and you're doing an RCA framework on it, and that's fantastic. But when you've actually identified the potential root causes, you've rectified them, and you do a review, say 6 months later, which is highly recommended, then celebrate that. Celebrate what findings you've had. Take a moment with your team and say, hey, everyone, we've done this together. It wasn't just me as a manager that made a decision and said, all right, you guys do that and go and fix it. It wasn't just the supervisor in workshop saying, hey, go tighten that and just fix it and get it done. It was a collective as a team that was involved in the RCA or in the repair, in the breakdown or whatever. And it's really important that you just take a moment to sit back and celebrate. Okay, if you're at work, you might be just having barbecues and not beers. Fortunately, Seb and I work for ourselves, so we get to enjoy a beer, which is always nice.
Our office is not on an industrial environment.
No,
well,
exactly.
Your office at the moment's in the middle of Australia somewhere.
Yes, yeah. Middle of the top end, just hanging out.
Love it.
And so I think it's really important, and I think, I agree with everything you just said. But one thing I wanted to come back to is where can we find some of these other successes? Like you pointed out, and we touched on briefly on the RCA, and like to make sure that we sort of do follow-ups. I think sometimes from my experience is like an RCA gets done, the root causes get identified, and then people go out and implement it and aim to fix it, and then it kind of just gets put over there. It's just it's over by the wayside. It's like, I think we did that ages ago. I'd like to suggest people follow up. Circle back, have a look and go, okay, last month, what RCA did we do? Oh, right, we did those RCAs. Cool. Where are we at with them? Have they been implemented? What's the results been? Oh, yep. It's been good. It's been this. Awesome. Fantastic. That's a really good result.
Yes. and that's
Likewise.
yeah.
Sorry,
You
go
keep
on.
going. Sorry.
No.
I think I was just thinking then that the positive energy needs to be injected into the maintenance department, because we're sort of like an evil necessary, if you know what I mean. You know, we're there to maintain the functions of the machine, but we're not a primary business role per se. And I think purposely you need to inject that in.
Yeah. I would certainly say one of the roles I had as a reliability engineer, it was certainly, you were seen as a cost to the business.
Mm-hmm.
You were something that cost the business money and time and stopped production.
Mm-hmm.
You know, all the things that you did, you're either fixing a breakdown that was costing the business money and time, you were organising planned maintenances which were costing the business money and time because it meant that things were being turned off, shut down, or moved out of the way. And you're utilising resources that maybe could have been doing something else instead of, you know, the maintenance that they were doing. So I agree. Certainly injecting the positive vibe. Certainly the people I worked with, they were generally quite positive, but they were also well equipped and been there for a long time. It's like, yeah, this is the way we do it. So we get our positive vibes from everything else going on.
Yep.
And I enjoy what I do, and it's all fine. I certainly think celebrating that success can increase that vibe, increase that positive frequency. And that's a very big thing in our lives. It's good for, if you take work aside, it's good for us physically, mentally, and emotionally to actually be positive, to look at these positive things and to celebrate these wins. You know, to be able to go home from work and instead of like dragging your knuckles going, yeah, day was all right, you get to go home and go, hey, we actually had a good day, we had a win, and you can be excited.
Yeah. And I'm going to also sort of mention something that I learnt from Ron Moore that he mentions in, I think it's Making Common Sense Common Practice in one of his books, is that celebrate, in the context of our conversation, is celebrate improving something. So one of the things that he talks about in his book and an attitude when it comes to maintenance, whenever you pull it apart for whatever reason, put it back together better than what it was before you pulled it apart. So take the opportunity to improve that, and I'm going to add to that, celebrate that success.
Yeah.
Okay. So, you know, I'm going to use the term laser alignment because you're electrical, and you know we're going to align motors to drive the mechanical things.
Yep.
And you know, people are rolling out. You know, well, it's commonplace now. Before it wasn't, but typically it's commonplace where things are expected to be laser aligned, like precision work being done. You know, we're using lasers and stuff like that. You know, and these things, you know, you do a before and after. Okay, we found software. We found this particular problem as a part of the laser aligning process. Celebrate that.
Yeah.
Because by doing that work, you've actually improved the machine.
Yeah.
Like what Ron Moore said. Or talks about.
Yeah.
So I'm a big fan of Ron's, by the way.
We've noticed.
Yeah.
That's okay.
Yeah.
That's good. So that kind of segues me into the other thing. It's actually what's flicking through the screen. So
yes.
For those that are new to this at the moment is what we call a dashboard. It's a dashboard in the machine learning platform of Horsburgh, or what we provide at Reliability Analytics. A very simple dashboard, and in fact it actually took about 30 seconds to 3 minutes, maybe, I don't know, to put together. The running comment is 30 seconds, maybe a couple extra clicks really, but you get the term. It's done quick. It's actually really quite easy to do. But when we talk about celebrating successes, and what I'd actually like to, we'll go through what this data is running across the screen in a minute, give you an insight into it. But there's little things going on that even so this is strut pressure or suspension
Yes.
pressure on
On a truck.
trucks. It's actually, as you see it moving, this is currently live somewhere here in Australia. This is this truck running around a site doing it. So that's what's going on. It's all live data as we speak.
You can see it. You can see it refreshing.
Yeah, you can see it refreshing every second it comes in. Now, there's little things that even I can see as an electrician here that doesn't know trucks very well. Can see it barking up. There's little things going on. So I'll let Seven explain it, but there's some little wins in there which I want to talk about when we get to them. So Seven, give us a rundown on what we're seeing and how it was sort of put together.
Let's use the technology.
Yeah.
I got my magic pen here. I was just setting up there earlier to use my magic pen.
Good.
Okay, so what we are doing is receiving some data from a truck, and we're actually running it through one of the sawbots, or the machine learning part of the sawbot. And the result of that sawbot is actually appearing right there. Okay. So this is the abnormality detection, okay, currently, and it's saying 61. Now, at this point in time, so if I just, I'll just clear that. Now, there's been some trends over time, and let me just stop this so I can point this out. So I'm just going to stop it from refreshing, so it'll stand still now. And this is some trends over time, and you can see here, if I just point there, there's a little peak on the mountain, and this is what what we call the suspension supervisor is saying, that there is a problem. So the general rule of thumb is, and hopefully you can see my screen, that any number above 80 is a definite problem. He's found a problem, and there's a peak. There's something going on here. So to interpret what he's trying to say is there's unusual behaviour. Okay, there's unusual behaviour. So this score is a rating on how unusual the behaviour is from what it has learnt. Yep.
Can I just chime in and I just want to add, and just to make it for everyone to get what we're seeing and some of the information. So you've got the basic overall. This is what we call the supervisor. So Seven and I coined these names, supervisors and luckies, which you'll hear as we talk about this. But that top line is basically the supervisor looking for problems and anything that is abnormal. So at the moment it's running at 61, which is it's not too abnormal, but if it gets above 80 on the abnormal scale, it's running abnormal. Now, this supervisor is looking at 4 tag. Is that correct?
4 tag.
4 tag.
Yes, four tags.
Yeah. So it's looking at front left, front right,
those guys
rear
there.
left. Yep. So up on your top right screen, it's looking at the 4 strut pressures. So it's just simply collecting the strut pressure from 4 parts of the machine, all live, all at once.
Yep.
Now, I'm just trying to put it very lame and very simple, because I know when we look at data, and I know you dive into this so quick, it's very common for you, and it's even very familiar for me now. So I like to simplify it so we can just all keep up and keep on the same page. So we've got 4 pieces of data. Note, that's only 4 pieces of data that we're seeing. This thing currently is absorbing 370 pieces of data from the same truck.
Yes.
So we just pulled out a very small piece of it. All right?
Yeah.
These things can be very complex. This is a very small piece. So I just wanted to highlight that so that we made it clear that that's what we're actually sort of seeing there. And as I think Seven was pointing out, those 4 tags with the 1391, 1313, that's all the actual pressure as it's going, like its current pressure.
Yes. That's its current pressure just here. Yep. That's it. Yep.
Cool. Please continue with your story. I just want to check in on that.
No worries. So we've got our abnormality score, and I was focusing in on this peak just over here. So if I mouse here, And the way that we've set it up is, if you'll notice, is if I mouse over anything on this plot, that it puts respective cursors, I'm going to use that word, cursors on the other plots on this diagram. So we can actually align and see what has actually happened at that point in time. Yep. So if I hover over that particular peak, okay, and you can see down here, there is a rather large peak in strut pressure, okay, where the strut pressure, one of these pressures, has gone beyond 4,000 psi. And you can see that peak is unusual compared to everything else. Now, what that means is that they've actually hit, well, I believe they've actually hit a bump in the road, a pothole in Australian terms, rut, or I'm not sure of other terms around the world, but they hit something on the road.
Yep.
Okay.
Could have been a rock.
Also,
who knows? Yeah.
Yep. Now, it's really interesting here because the peak appears down the bottom here, okay, and doesn't necessarily appear here. Now, this is our front differential. So what we're doing is we're taking the left front strut and the right front strut, and we're simply taking the difference between the two and plotting that. And we're doing that live. And this one here is our rear differentials. So if I was to interpret this, okay, we've hit this pothole, and we've hit it on one of the struts that happens to be on the rear. So we've hit a big bump on the rear. Okay.
Yep.
Now I could increase. I could, obviously help the visual along a little bit more, where we could actually look at the individual struts and identify exactly which strut it is. But the machine learning is constantly reviewing this stuff. So if I turn the screen back on, okay, so this is for the last 30 minutes, and I can now say refresh this visual every 5 seconds. And if I just leave my scribbles on there, you'll actually start to see the screen starting to move relative to
look
my
what's
visuals.
Coming up, though. Look what happened.
We've just found another bump. Look at that. Is that what you're pointing to, Dane?
Yeah,
yes, just hit another bump.
That's what I'm pointing to.
And look at that. Let's test this. Let's mouse over here. Sorry, look at the right screen. So let's mouse over here. And that's interesting. It's actually saying that's okay, this bump here. If I just clear my screen, have a look at this. It's actually saying something's just unusual just happened. Let me just stop this. Something's just unusual just happened in there. So something has unusually happened in here, right there. And have a look at this. A bump there and a bump there. Look at that.
Look at that.
Look at that. So I've just had a slight epiphany here. So what we're doing is we're using the results of our supervisor to tell us that we've got a problem, i.e. we've gone above 90%. And immediately now we're trying to find the cause of that by drilling into the data that's actually being presented and trying to identify the behavior. Now, I think we might be able to improve this visual because we're recognizing the bumps. And if I can improve those visuals so that we can see what that actually means, we can zoom in. So I can do a little zoom in on this, and I can see the bumps here. Now, let me just clear the things. Now, I've got dots that sort of are telling me there's the bump there that correlates to this bump here.
Yeah.
So if I mouse over these things, so I need a little bit of work on these things. But you've got the idea.
We've got the idea.
Yeah. Now, I was trying up the top here with this guy here. This is the ranking from what we call the ranking from, or tag ranking from the machine learning.
Mm.
And if I zoom in here a little bit further, there you go. All of the others are even, and that one has dropped.
Front left rank. Ah.
So the front left is not it's behaving differently to these
And
three.
just notice that if you have a look then over at your strut pressures.
Oh, look at that.
So the front left drops dramatically in comparison to the other one, which means that the pressure increases on the right, obviously, and so it blows it out. So
we've twisted.
Yes, you've actually twisted the front end.
Wow. And I'm just looking at the differentials down here. Look at the differentials. They've just gone red.
Red.
Wow. Okay. I think we need to overlay some GPS data to find out where this happened.
Aha. And that was where I knew that we were going to be able to get to. So then now with this, again, this is just explaining how it works and how simple. It's like just something simple like strut pressures. So those of you that have been watching for a while, I'm driving around Australia in a bus. All right. It's a rough ride half the time, but most of the time it's actually pretty smooth. We hit bumps and it's rough. But to actually observe how this works, you imagine a truck driving around a site and then you hit a pothole. It's the same thing with the car. All of a sudden you're putting a pressure and a stress on the car, which can twist the front end a little. It sort of out of balances it and throws it out. And you wonder why the things rock and roll as they kind of drive along. But then, so from this data at this point in time, so one thing to point out here, Seven, is, like you said, you go across the top, you find where that anomaly score is high, you pinpoint it, it tells you all the other pressures at that time. It also gives you a time of day down to the second. And then, because these machines have GPS, we actually go back and have a look at where they were at a GPS, and we can pretty much pinpoint there's a hole in the road here.
Well, I'm actually thinking, here's an improvement whilst I'm actually on the run. Wonder if I could squash these guys up and put a little map just in here with the GPS location.
I think that'd be a really good thing.
Yeah, right. If I could get the GPS location, I think that would be. Yeah,
I think.
But you can
see
that differential there. Right, have a look at these two. I think I need a bit of work with the color coding, but you can see we've got that differential sort of covered in because it's the two front ones that are different. I know I'm making a lot of mess here, but I think I need a little bit more work on this, but it's coming together.
So just zoom back out a little bit. We've discovered that we've hit the pothole. We've identified that we can do that. And while you're zooming out, one thing, like I said, Seven was showing me this before we got online, and it was like, hang on, this is interesting. But this is one of those little successes that could be really easily celebrated. You could get a message, like if you're a reliability engineer looking after this fleet of trucks, and you get this little message, hey, truck, this suspension barked up. And if you weren't watching it, but it was sitting on another screen, and you just clicked on and went, there's a pothole, hang on, or in this area of the pit. You could ring up the production supervisor and go, hey, can you have a look at this section of the pit or this road? I believe there's a pothole and it looks like the guys are hitting it. Because if you even actually go back on that data, if you can zoom back a little bit for us, or sorry.
Zoom back in?
But, no, stay out, but go back in time.
Oh, go that way.
Yes. So you'll probably notice one thing I kind of wanted to point out, and this is just a little bit of my observation, is you can see when the pressures are higher and then when the pressures are lower. Now, these are trucks that are loaded with coal, rock, or other bits of rubble. So obviously when the pressure's up is when they're loaded, and when it's down, they're empty. But one thing I noticed before Seven was that anomaly score jumped up towards the end of that loaded period.
Yep.
So it was potentially towards the end of their route. before they
Yes.
unloaded.
Yes. Yes. Yep.
Yeah.
Yep.
So
Correct.
it was the same sort of area. So it was not
So
like
it's-
you like
He
he just hit
there-
one pothole, one driver could have been.
Yeah, there's one there. So that's right near the end.
Yep.
You can see it's travelling along here, and it's just
Yep.
It's So that's this bit there is where they dump. So that's the dump.
Yes.
So they unload here. Yep.
So I think there's some of the little things that you could then do. Like if you were, as I said, the reliability engineer, you get this message like, hey, production manager or supervisor, I'm just having a look at the data or data for the Americans and others. It looks like we're hitting a bump towards the end of the route. I haven't got the GPS location, but it's towards the end of the route. Can you get someone to have a look? They can go out, put a couple of cones around it. All of a sudden, the struts are doing less work. Quick celebration, high five, good work. Move on.
That's it. And you could actually get instant feedback on that because this guy's not going to be barking up anymore.
Exactly. And it's,
you know you've solved the problem. You've got you've got data to prove it because every time somebody runs over that thing,
we've got
a problem.
Exactly. And like we're only talking about one truck, and just going around that sort of route. It could be just the driver cuts a corner a little bit too much or whatever else. But either way, we get to actually point out something to actually rectify a problem and fix it sooner. And that's one of the things I like about the machine learning is that it is so simple to catch it quick and move it forward and fix it sort of straight away. And you get those wins, and it can be that real simple little win. But the effect of that on the truck is quite significant. If you imagine hitting the same pothole every day constantly,
yes. I was just going to go. Sorry, I was going to look at the right screen, Seven. If I go back to here, right, and I might even zoom right into there. And I was just going to say, the difference between there and there, in this case here, is something. If I look at those two numbers, I'm going to call it 300 psi.
Yep.
Whoops, psi. Very bad writing. So we've got 300 psi difference. We could actually do some numbers and convert that into a force, i.e., we've just twisted the truck and applied this amount of force for this duration.
Yep.
On that truck whilst we hit that bump. So the structural people would be able to figure out some sort of formula on what fatigue we've actually created on the chassis now that we're collecting this type of information.
Wow.
Forecasting fatigue life. Forecasting fatigue life.
Yeah. Because one of the big things that we've been talking about with clients is some of the other things that don't get measured. Like I come from, again, the electrical world, so we have a lot of things that just get measured. It runs when it runs. You don't see it. When it breaks down, it just stops, sort of thing, or things stop. But I certainly can respect the mechanical side of things, and like you said, that fatigue, pressure. Like we've also been talking to people about how you get cracks and wears, and the effect of vibration on cracks and wear, and moving parts, and like you said, the chassis twist. So that's probably something that doesn't normally get taken into consideration, is how rough the road is, how often
how rough the road is,
and what impact that actually has. So again, something else to celebrate in the successful route of talking is, hang on, we actually have an opportunity to evaluate the importance of the condition of the road. Not just suck it and see and go, oh, well, bumps aren't good. It can damage a truck, but I don't know. Might last another 5 years, might last another 10 years. It kind of just lasts. You kind of get the opportunity to dive a little deeper and really understand why and how much of an effect that is having.
Yes. I'm guessing we could probably feed this data into an FEA, finite element analysis, and actually, calculate the change in stress in the chassis as you twist and move. But anyway, that's outside my area of expertise.
It is, but Seven, recently I drove the bus up to the very tip of Australia, right up the way to Cape York. As you know, we've spoken about it, for the people out there and the people across the world that might not have a clue of what the tip of Australia is like. It's around about 1,000 kilometres of dirt gravel road, which gets highly corrugated because thousands of people drive it every dry season, which is only about 3 to 4 months. And the bus was shaking, the bus was rattling, the corrugations were quite big, and I could imagine it had a lot of pressure on.
Yes. Well, evidence of that was things were falling off the bus, weren't they?
Yes.
Things were falling off the bus.
Things were falling off.
You were telling me the story about that.
Yes. And it was. I did have a couple of things fall off. I do take part responsibility, and that was probably my not quite appropriately mounted. But hey, we learn. But even that, like, I spoke to a bunch of other people on the road, and people had like other fittings and so forth just wobble loose. They went and checked them, serviced them, but they had handbrake applications fall off, jockey wheels sort of fall loose on trailers and bits and pieces. So it's kind of one of those things that doesn't necessarily matter how well, like it does matter how well you look after it. I'll correct myself there. But these things will happen. Like, things will come loose. Things will vibrate loose. And
because of the operating environment.
Exactly, the operating environment.
Operating environment. Mm-hmm.
Yeah, and I think that's one thing that really needs to be considered in the industries that we talk to, or in any industry. You know, whether it's a factory that has a high level of chemicals or high heat component, like everything shifts with heat. You know, or if it's extremely cold environment, metal contracts, it shrinks. You know, these things change. So understanding the environment, understanding the conditions of the roads, of the moving parts, of everything else, can really help us hone in and go a lot further with reliability. And I think this is one thing that excites me about what we do, Seven, apart from the podcast, because we know we get excited about this. Is opportunities for these improvements, the opportunities for the wins. You know, like even just now, you had this because you got asked to do this in a presentation 2 days ago, and you slapped it together in 30 seconds. You know, you just picked the tag.
30 seconds, mate. To be fair, it was more than 30 seconds.
I'm giving you a rap.
Yeah, thank you. Thanks, mate. Yeah, for the listeners out, it was more than 30 seconds. But it wasn't half a day, I can tell you that much.
That's right. Like it was a matter of minutes. Is really the point. And in a matter of minutes, you're able to get this data. And now we've watched it for a little while. We've been able to hone in. We've seen something happen, gone, oh, hang on. And then on goes this array of other things, which usually in our world, as reliability engineers, don't get the chance to do.
Yeah.
And I think we've spoken about it in the past that we all want to improve things. We all want to do a good job. We all want to have some sort of success at the end of the day that we go home and be excited about. I know one of the guys that we had on, Steve Davies, a couple of weeks ago, talked about how fitters aren't fitters necessarily anymore. No offense to them, but the electricians are the same. Like, they're often just changing parts, doing the tick and flicks, just going through the process. We want to help empower them with an opportunity to actually improve and to learn. I think by doing these, like, our plan is that we actually decrease downtime. We improve maintenance efficiency, so you're doing it less frequently, more sustainably, and more practically. And then when you you're getting to breakdowns before they break down, so you get an opportunity to fix it before it happens, and we're getting a chance to learn.
Yes.
We're getting a chance to educate people and help people understand.
That's it. Understand. That's the word I'm looking for. Understand what's going on. And then once you understand it, you can do something about it. You come up with some awesome solutions.
And having the time, I think one thing we've talked about before, but having the time, because like you could have a breakdown and then you could take the time and you could understand the problem, but it's broken down, so you need to get it fixed, and it's like run around like a mad hatter with your, the tea party's going, I've got to get things sorted, and you get it sorted, and it's like, oh, right, okay, well that fixed it. But what did we really do? Or how did it work? Whereas potentially, in this case, like this truck hasn't failed. This truck's still driving.
Yep.
Its chassis hasn't fallen off. The wheels haven't fallen off.
I better prove that and just show that it's still actually traveling around.
Yep.
There we go.
But even yeah. So, like, it's still driving around. It's still doing its thing. But we've got more opportunities to actually improve the process or prevent other failures. Have the truck run longer. So, like their successes, even though this is so minor, and I'm going to blow it out to a massive what if. Okay, so we're talking about strut pressures. We're talking about someone constantly hitting this bump on one side, putting added pressure. Say, highly unlikely, but say that the chassis twists so much in this time and it starts to put a crack in it. Once that chassis cracks, how good is the truck?
You got to fix it. you don't want the wheels falling off, literally.
Exactly, you don't want wheels falling off, literally. And it has happened. But there's a massive cost to then do that. Like, you think about it. If you even for those that don't work on these big trucks or haven't been around them, and I know when I get around them, I still get a bit gobsmacked, but I've spent a lot of time under my beloved bus, and I can imagine that the added pressure, if there was a crack in the chassis somewhere, even if it was repairable, the process, the time, the effort to actually pull the engine out, pull everything out, dismantle it, clear the space, fix the crack, or even if it's just on the side and it's just near the wheel hubs, you've got to pull them all out, get everything out of the way, re-weld it, test it, confirm it's sorted, put it all back together. You're talking, on a bus, you're talking days to weeks. I mean, one of these big trucks, it's much longer. So those downtimes, they're things to celebrate. They're things to actually go, hey, we found something. And then all of a sudden, the reliability engineer becomes the good news reporter. He's actually someone that's going, hey guys, we got an opportunity. We fixed the road over here. We fixed the pothole. So that means our truck's going to last longer. And we don't have to worry about that. Like, we'll still look at it, but we don't have to worry about that sort of thing. So I think that's a really good thing. And I think there's a lot of little opportunities, but when you started talking about and showing me this tonight, I was like, oh, it just came to me. This lines up with what I wanted to talk about. I wanted to talk about success. And so before we do run out, what have been, can you list or talk about, give us a brief talk about one of the most memorable successes in the world of RCA and one in machine learning. But let's go with RCA first. We've left RCA for a little while. So what's one of the most sort of memorable, successful wins that you've seen and gone, wow, that was actually a really good result and we kind of won, and that's great?
I think the greatest, It's actually not just one RCA. I'm going to say that is what I'm going to talk about. The greatest win of using structured problem solving that I've had in my career is by applying it, turning a production process from not keeping up to something that we had to stop and rejig the maintenance strategy because it was producing too much. That's probably the one, and and I'll come back to that's not just one RCA, that's multiple RCAs and a little bit of discipline and doing the RCAs, and we got that result. And you know, that's something that I'll probably, you know, remember for the rest of my life. I do remember that story, and that was a very good news story. And I think it is important to just touch on that and say, look, you know, it was a number of RCAs. It was a little bit disciplined, but like you said, and I remember when you were sharing it with someone else, and I sort of you're sharing with a client that we were both working with at the time, and I kind of just bit my tongue in the case of, oh, yeah, I already knew this, but then I walked out of there thinking, oh, wow, I didn't quite realize you'd turned that around. Because to summarize, and you can tell me if I'm wrong, but this particular plant was running 7 days a week, non-stop, occasionally shut down for maintenances in different areas at different times, just to keep up with production requirements. And it was often in breakdowns. By the time you departed, it was running 5 days a week. All maintenance was done on weekends. No. Different one.
Oh, different one? Okay, sorry.
Different one.
Might have still been running 7.
Yeah, it was still running effectively 7 days a week, but the maintenances, we had different maintenance windows during the week. Okay, so we didn't have to do weekend work.
Okay, sorry. Mismemory.
That's
but
right.
Still, like, all of a sudden you've got opportunities and windows, and you're actually ahead of production or keeping up with production. Like, production's...
Yeah.
You're no longer going to production, hey, can I have this piece of equipment so I can maintain it? They're going, oh, well, we don't need that this week. You're like, okay, cool, we'll go maintain it that week. Yeah, like...
I can hear them. They're comfortable. Production is comfortable with where they are because the equipment is performing and producing, and the answer, instead of being no, because I really, really need it, to yes, you can have it.
Yes.
And then you can do the Ron Moore thing, improve it when you pull it apart, and things just incrementally get better. Things just incrementally get better.
Incrementally getting better because you're no longer under the stress of like, shit, we got to get this done, we got to get it moving, we've only got 12-hour windows. And having done a lot of time in the maintenance side of things, you know, 12 hours, you hope to get X done. Usually you get Y done, but that's about it. You know, whereas you're saying you get the chance to do X plus Z and Y now because you're on top of it. And you've got a bit more time, and there's no time pressure. It's like, okay, you might go, okay, usually we'd plan 12 hours, but the production said, oh, okay, you can have 24 hours in that period. And you're like, okay, sweet. Yeah, we can take our time, not feel time pressured. So, awesome. So what about the machine learning?
I think for me, with the machine learning, there's actually a couple, but I'm going to go for one. We did some work for some people. They gave us some data and we analysed it through the machine learning. And I said there was in the results of the machine learning, they had an instrument failure. So they had a sensor go wrong. Yep. And I said, Joe Bloggs, Mr. Joe Bloggs, you had a sensor failure on this date and time, and then you repaired it by here. And the answer was, did we? and I said, yes, you did.
Yes, you did.
And they, yes, you did. And he goes, are you sure? And I said, I'm definitely sure something happened with this instrument. It looks like an instrument failure to me, from the data. Oh, no one told me about that. I need to look that up. and he went away, and it was written in one of the operator logs.
Yeah.
He didn't know about it. He didn't know about it. It was written in one of the operator logs. They'd sorted it out, and and that was like the results from the machine learning. Like one of these guys, actually told me that.
Yeah, yeah. So something again, just so quite simple that and it's a case of, and when you talk about success, that's actually really a job well done by the technicians to have fixed it. They found it, fixed it, and it's all happy days and no stress. And the manager or supervisor hasn't got anything to be upset about, but it's good to know, right?
Yes.
It's just a good to know thing. And I think something that's important to recognize, and we sort of pointed it out in the past, but sometimes when we get through the process of just fixing things, just replacing things, just keeping it on the run, or if you've been in an area for a long period of time, like that technician, for example, might well have just been, yep, that plant's not showing up, 98% sure it's a sensor failure. So I'm walking down, I'm picking up a sensor, I'm going and changing it, and I just tick it off and get it done. Yep. And he just knew, But now when we have the data to actually show that, we can actually just earmark it and say, hey, we've got a sensor failure. We could look for any, anomalies that would indicate that the sensor's not operating correctly. Or you could just mark it in the line, and then when it does fail, the instant it fails, instead of maybe he realised it a shift later or a little bit later, he could bark up and the reliability engineer could go, hey, XYZ, go and fix your sensor failure. And now it's not on that technician himself just to remember that, but all the other technicians get to know that.
Yes.
They all get to know. They all learn from that.
Yes.
So,
Awesome. Righto. I better call it a night, mate, because I need to have a human break.
Fair enough. That beer has gone through. No, that's awesome. I did want to just touch on those successes. So thank you, Seven. That was really good. Like I said, I think it's important that we do share successes. I wanted to highlight to everyone that we are pretty casual, and look, we're human too. We need human breaks. But we had a little success in our business. We wanted to share the importance of that and try and encourage you guys to look at those things. What Seven got to present us here was a nice little demonstration of how the Zorba product works and just how we can pick up some of these small wins. It doesn't matter how big the win is, it's always worth celebrating, having a little bit of a cheers, a high five, or give someone a pat on the back at the end of the day. So with that, thanks everyone. You guys all know the way to go about it. Smash the like button, subscribe, leave comments, check us out, and reach 7i on LinkedIn, or via the website, anywhere you need to go. So thank you very much. Take care.
Yeah.
And see you soon.
No worries. See you later.